Unit 3, exam review. I just started working on it here. You need to draw a figure so that the reflection over line S of triangle MNP is congruent to triangle MJK. Since M appears in both parts, M must be on the line. Make sure you look out for that. Now, it doesn't matter where N is, and it doesn't matter where P is, but the reflection of N must become J, and the reflection of P must become K. So I'm going to go ahead and use my mirror to reflect them real quick. Reflected N and a reflected P. So the reflection of N, as I said, is J because it comes second, and the reflection of P is K. And now using a straight edge, I'm going to connect my points to make the triangles. Like so. Number 2, in the figure below, draw the reflection image of ABCD over line K. Obviously, you're just going to get your mirror out and reflect each point using the correct procedure that you were taught. And I'll do my best to do that right here. I'm going to turn the light on, actually, so I can see. So there are my points. I'm going to label them. This is D prime. B prime is up here, this is C prime, and this is A prime, and then once again, using a straight edge, I'm going to connect the points. It should look the same. Number 3, give the image of R comma S when translated by the vector 8 comma negative 7. You just combine R and 8, so that becomes R plus 8, comma S plus negative 7, which I'm going to write as S minus 7. And you're all set there. I have the vertices of triangle RNT. I want to know the reflection image if you reflect over the y-axis. Remember, if you reflect over the y-axis, the x-coordinate changes. So that means that R would become negative 5 comma 9. That means N would become negative 4 comma negative 8. And that means T would become positive 7 comma 8. For number 5, true or false, translations preserve collinearity. Remember, all transformations preserve angle measure between this, collinearity, and distance. So that is absolutely true. The only thing that isn't always preserved is orientation. We'll talk about that hopefully in a little bit. For this one, we need to reflect triangle ABC. Remember, work from the inside out, so we need to reflect over M first. Using my mirror. I cannot see A, but I can see B and C. And A is so close I can reflect it. This is a very small figure to reflect. So this is A prime, C prime, and B prime. And now I need to reflect my reflection over N. Remember, you always reflect the reflection. So taking what I had reflected and finding that, I'm going to make those points. And it's going to come down on top of letters here. But that's okay. Yeah, connect the points. Should use a straight edge to connect, but it's pretty small. And this becomes B double prime, C double prime, and A double prime. That's what you should have there for part A. Again, you came down here. Name the transformation. If you reflect twice over intersecting lines, it's a rotation. Its direction, again, starting with your original and going to your final, the shortest distance, so that direction is clockwise. And since it was clockwise, we have a negative magnitude, and you double the angle measure to get your magnitude. So we have a magnitude of negative 90 degrees. That's page 1. Page 2. to rotate a segment by 150 degrees around point R, you can reflect it across two lines that form an angle of blank. Remember, you double the angle to get your magnitude. So what do you double to get 150? 75 degrees. And the vertex is just the point that you rotated around, so that would be R. Number 8, in the figure below, wants to know what the reflection of D is. Well, if you look at it, D reflects onto Q. And what the reflection of S is on the line, so the reflection of S is S. If the reflection of R equals E, then K, the line, is the blank of the line RE. Remember, it's two things. It's the perpendicular bisector of RE. Number 9, in this figure, angle GHA, that is this angle right here, is 156 degrees. Find the angle GHD. Well, if this bisects this angle, that means it cuts it in half. So GHD right here is half of 156 degrees, which is 78 degrees. For number 10 of the figure, we're going to draw a translation image translated by WZ. Okay, notice how it starts at W and goes towards Z. That means our translation vector is this line, or this ray I should say, that I just drew. That is a translation vector. Every point has to move to the left parallel to this ray, the distance of that ray. And I'm going to measure that ray right now. That ray has a distance of about 1.5 centimeters. Okay, so now I'm going to take each point and I'm going to go 1.5 centimeters. W already is all set. It lands on top of Z. Z is going to come out 1.5 centimeters. Oh, I'm off the screen. Z is going to come out 1.5 centimeters. It's right here. Okay, and now I'm just going to try to run my other points parallel to that line 1.5 centimeters. So for X right here, set it up at 1.5 centimeters. Looks like I'm pretty good to parallel. I draw a dotted line, put X at the end of it, call it X prime, and I'm all set. Same thing for Y. I'm going to try to get parallel to my vector, 1.5 centimeters. I'm going to go out from there, and I'm going to make Y prime. And I'm actually going to flip it over so I can see that I'm parallel here. That looks pretty parallel, 1.5 centimeters. That's my new U. And same thing with V, although V is going to land right on top of U. Okay, so this becomes V prime and this becomes U prime, and as always, use a straight edge to connect your points. And you got to remember what order they went in. U connected to V, so this is a part of my segment. V connected to W, well W is where Z was, so that's going to go right along with that. W connected to X, so that's going to go right there. X connected to Y, Y to Z, and finally Z to Z. And you should get a figure that looks the same, only has shifted the distance of the vector in the direction of the vector. Number 11, name the type of isometry that maps figure 1 onto figure 2. Well, it looks like if I reflect this over, their orientation is not preserved. This looks to be point A, we can call it point A. This would be point A prime, that kind of that point that sticks out, so it was flipped over. That means it's either a reflection or a glide reflection. To check and see, I would set a mirror between them and see if I can get them to land on top of each other. I can't. So this would be a glide reflection. I would have reflected figure 1 and then had to slide it or glide it or translate it down. So glide reflection there for number 11. Almost done. Number 12, name the type of isometry that maps figure 1 onto figure 2. Orientation is preserved here. You can clearly see that the B's are facing the same direction. If orientation is preserved, it must be a rotation or a translation. If you look at it, you're just kind of rotating the B up. So we're going to go rotation there for number 12. For group figures, they're the same shape, same size, use the same amount of ink. Definitely without doubt is C. Those Z's are just switched. The 4 types of isometries. We started off with reflections. And then we went to translations. Translations are just two reflections over parallel lines. Then we went to rotations, two reflections over intersecting lines. And finally, glide reflections. We reflect, and then you translate. Number 15, the isometries that preserve orientation. I just said this. The ones that have a reflection in them do not. The ones that preserve orientation are rotation and translation. Those preserve orientation. Reflect twice. Draw and label this figure so that the reflection over line M, so once again, just like number 1, we need to draw line M. Draw a line, label it M. The reflection of xy is x prime y. Well, notice how y didn't get a prime. That means y must be on the line. X can be anywhere you want it, just so that the reflection of x becomes x prime. And there it is, using the mirror. And finally, connect the points with the straight edge. There's xy, and there's its reflection, x prime y. Finally, number 17, last one. Give the coordinates of P when you reflect over the y-axis of negative 26, 42. Remember, if you reflect over y, that changes the x, so this would be positive 26, 42. And P is the image of negative 19, negative 18 when it's translated by the vector of 20, 18. In this case, you just add the x parts. So I have this point, and I translate it. So I add negative 19 and 20, that gives me 1. And I add negative 18 and positive 18, the y parts, and I get 0. So the answer is just 1, 0. That is the Unit 3 exam review.